Okay, now we'll see the what we have discussed. In the previous session, we discussed about the single rotation, right? So in that we discussed about the left rotation and right rotation. Now we'll discuss the next part, that is the double rotation, right? So sometimes, so single left, when we require the double rotation, so what is the purpose of double rotation? Now sometimes, so by performing the single rotation, so we are not able to convert the unbalanced tree into the balanced tree. So sometimes we need to apply the double rotations. So in that case, so or we'll say single rotation is not sufficient. So at that time we'll go for the double rotations, right? Now double rotation, again it is categorized into two parts. One is the left-right rotation and second one is the right-left rotation, right? Now here the example of the both rotation is given. What are the two types? First one is the which one? Left-right rotation. And second one is the right-left rotation. Right. So how to perform the left-right rotation? So here in the first diagram. So online student, is it visible to all?
Yes, sir.
Okay, good. Now left-right rotation. So here, how it is performed left-right rotation? So here, the simple tree we have considered. So what is the, now you can see here. So cursor you can observe. So this is the tree, right? A, B, C. So what is the BF of balance factor of C? Here, balance factor of C.
0.
Right. And balance factor of B?
-1.
So why it is not +1?
Because 0 -1. -1.
0 -1 -1. Good. And now next one is the A. So what is the balance factor of A?
+2.
+2.
Now here B and C both are left side of the A, right? So here the 2 minus 0 we are considering. So is this tree is balanced?
No.
No, sir.
Right. Now by applying the single rotation, is it possible to balance the tree? Now we'll apply the left rotation first. So after applying the left rotation, C will goes to the up and B will be moved down, right? Now we'll apply the left rotation first. So after applying the left rotation, so what will be the outcome? So here A, after that C will be at middle and B is at left of the C, right? So here which rotation we have applied first? Left rotation, right? Now immediately, but still we have, till the tree is balanced or unbalanced? Unbalanced, right? Now in such situation, so we need to apply the double rotations, right? Now immediately, which rotation we have applied here? Right rotation, right? Now after applying right rotation, C will be at root node and A will come at the right side of the C and B will be at the left of the C, right? Means here, so how many rotations we have applied on this?
2.
2. First we have applied left rotation and after that we have applied the right rotation. So this is called as a left-right rotation, or we can call this is the double rotation. right? So this is called as a double rotation. So in this method, so balance factor occurs between +2 or -2, right? In the above example, so balance factor is occurring +2 or -2. So this balance factor, we need to convert it into the either 0 or 1 or -1, right? Now here, in this way, we have applied the left-right rotation, right? After that, next one is the right-left. So how to decide this left-right or right-to-left? So that is depending on the structure. So by observing the structure, we are able to understand, right? So which rotation will be applied here. Now you can observe the second diagram. So here right-left rotation is applied. Now you can see here. So what is the balance factor of C? 0. Balance factor of B?
1.
Balance factor of A?
-2.
-2. Right. Now, so which rotation you have to apply first? Here.
Right.
Right rotation. So why you have decided right? Because the lip means C is present at the left, so we have to apply the right. So right is applied first. So C will be at the position of B and B will be at the position of C. So we'll apply the right rotation, and till applying the right rotation, still the tree is not balanced, right? So again we'll apply immediately, we'll apply the left rotation, right, left, right? Now after applying the left rotation, so C will be at root location and A will be at left of the C, and here the finally we will get the balance rotation, right? So in this way we are applying the double rotation. So this is called as a double rotation. Single rotation, we are applying left rotation, right rotation, and in the double rotation we are considering left right. Immediately we are applying left as well as right. Here for our understanding purpose, so I have written the separate step. So you can directly write this third step also, right? So not an issue, but for understanding purpose, this middle step is written. This is called as a double rotation, left right rotation and right left rotation. Now here these are the examples, so you can go through the examples. Procedure for double rotations. So here you can see the is it visible to all? Yes.
Yes.
Online guys. Huh.
Yes, sir.
Yes.
Yes, sir.
Okay. How many nodes are there in the first
5 nodes.
5.
5 nodes? What is the balance factor? Balance factor का है?
-2.
-3.
-3 or +3?
3, sir.
Hmm?
+3.
Your offline student is saying +3. You are saying -3. So which is
Plus 3.
+3, sir.
okay. Online minus दिसते का? नहीं ना?
No, sir.
Now I have to mention here online, offline. So few of the students are attending offline and you are attending on virtual mode. So try to understand. Sometimes I will call online and sometimes I will say offline. So here A, B, and what is the balance factor of B? -2. Balance factor of C?
0.
Balance factor of D?
0.
0.
Balance factor of E?
0.
Is it necessary to apply the rotation? Is it required? Now how to apply? Now here step 1, C takes the ownership of A. C takes the ownership of A directly. So directly C हा A ची ownership कशी काय घेऊ शकेल? So which rotation you need to apply here? Single or double? Now you can observe here. So we have seen. So C is taking the ownership of A. But when? After applying the double rotation. Which rotation we have applied here? Left, right. And here? C is directly taking the ownership of A, but after applying the 2 rotation. The same here we will use. So here which rotation you have to apply? Right, left or left, right?
Left, right.
Left, right. So first you need to rotate C at left, means B will take the C will take the ownership of B, and after that C will take the ownership of A. So to take the ownership of B, C need to do the left rotation first, and after that right rotation. So here left right rotation will be applied. Now by considering the left right rotation, so here the steps is written. So C takes the ownership of A, right? Now C becomes the root and A becomes the right child of a
C.
C. So here A is written. So actually C is required. Now B becomes the left child of
C.
C. So actually here C is there, right? So but by mistakenly A is there. Now the AVL tree is CBA. Now in the given tree, the AVL tree, the right child of the C becomes the left child of A, and the left child of C becomes the right child of A. Now this is the procedure. So we are following at the time of double rotation. Next diagram. Now which rotation you have to apply here?
Right, left. Left.
Right, left. Is it necessary to explain?
No.
Now C takes the ownership of A, B becomes the right child of C, right? And A becomes the left child of C, right? Now in the given AVL tree, the right child of C becomes the left child of B, and the left child of C becomes the right child of B, right? Now here few example is given. So you can go through these examples and solve it. So I will share this PDF on a group. So you have to study and you have to complete this one, right? So here the AVL tree example is completed. Now this PDF I will share it to you all. Now all of you have dictated the double rotations. So this part. So all of you have dictated in your notebook first. All of you have dictated in your notebook first. Your banking is now we need to the real time application is the best example some of that can be there's that's the inheritance of subscriber. That's the multi-level hybrid. Data structure actually data is from the market. Data duration फॅमिली मेंबर सगळ्यात वयस्कर आहे आजोबांचं आता उत्पन्नाचं आजोबांचं नाव असतं वडिलांचं नाव त्यांच्या नावावर सगळं ते ऑनलाईन झाल्यामुळे पहिलं ऑफलाईन त्याच्या नाव पाहिजे नाव पण आता ऑनलाईन म्हणजे हे सगळ्या गोष्टी फॉलो करतात एक्झाम्पल घेऊया So I am expecting example तुम्ही सॉल्व करू शकता का एक तर करा आता इथं आपण फक्त डेटा स्ट्रक्चर बद्दल डिस्कस करतो इनहेरिटन्स हा ऑब्जेक्ट ओरिएंटेडचा पार्ट आहे हा इनहेरिटन्स लिहू वापरू शकतो हा हा ऍक्च्युअली डेटा स्ट्रक्चर आहे इनहेरिटन्स हा प्रोग्रामिंगचा कन्सेप्ट आहे उप्स आपण आता हे जे डेटा स्ट्रक्चर आहे all these data structure we can implement by using the any languages so by using the C programming language we are able to implement all the data structure all the algorithms so by using the C++ also we are able to implement by using the Java by using the .NET by using the Python also. You can use any programming language but so why we are considering C so because you are aware with the C programming language that's why we are using the C and in the syllabus also they have mentioned prefer the C. So all of you written hello online student
Yes, sir.
Yes, sir.
okay. Now this procedure also you can dictate so this one and this one so these two procedures you can dictate after that we'll see the example procedure for double rotation. Now here instead of A you can consider C. So here in the step 2 and step 3. All of you are written. Hello. Those who are attending the online session. So all of you have dictated the double rotation.
Yes, sir. Yes, sir.
Okay. So now we'll see the examples how to construct the AVL tree by considering the element. So now you can click on the cameras. So now this is the last part of this unit. So we'll see the constructions of AVL tree. Camera is visible to all?
Yes, sir.
Construct AVL tree. Is there? Now, what is the first step? So, construct the AVL tree from the following elements. So, how many element is given here? 50, 20, 60, 10, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 element, right? Now, first step. What is the first step? So, insert the first element. First element is 50. So we'll consider 50 as our root node. 50 का consider करना है, root consider करना है, right? What is the balance factor of 50? 0. Now next step, 20. So where to insert 20? At left or at right?
Left.
So what is the balance factor of 20 now? 0. Now what is the balance factor of 50?
1.
Is it necessary to do the rotation here?
No, sir.
No.
Now next third 60. Now I am expecting the answer from your side. What is the balance factor? 0. Next. After that, next one is the 50.
0.
Next element 10. Where to insert 10?
Left side of 20.
Left side of 20.
Left side of 20. What is the balance factor of 10?
0.
0.
0. Right. After that, next one. Next element 8.
Left side of 10.
No, so sorry. Here, what is the balance factor?
1.
1.
Now, next element. Next 8. Where to insert 8?
Left side of 10.
Left side of 10.
What is the balance factor of 10? 1. Balance factor of 20? 2. Balance factor of 15?
2.
Now the tree is balanced or unbalanced?
Unbalanced. Unbalanced.
Unbalanced. So what we need to do here?
Rotation.
Rotation. So which rotation? left rotation. So can I rotate this one? So like this. So 50. Now here, so 10, 8, and 20. And here is the 6. Which rotation we have applied here?
Left rotation.
Left.
The right rotation. Right.
बरोबर आहे का?
Right rotation.
Right or left?
Right rotation.
Right.
10-20 या ठिकाणी आणायचं असेल तर कुठलं रोटेशन आणणार? लेफ्ट का राईट? आताच विसरलं लगेच. लिहून घेतलं ना सर्वांनी? हा, गो थ्रू युअर पॉइंट्स. सो कन्फर्म विच वन, लेफ्ट और राइट?
Left rotation.
Yes. Here, online students, you can put your answer in chat box. Left or right?
Left rotation, sir.
Which one?
Left.
Left.
Yes.
So you can consider this one only. So 20, 10, and 8. 20, 10, and 8. कोणतं रोटेशन पाहिजे? राइट रोटेशन you need to apply. Right rotation. Right? So after that, so you will get the tree like this. Now what is the balance factor of 8 now? 0. What is the balance factor of 20?
0.
Here.
0.
Here.
0.
Here.
1.
Now the tree is balanced. Tree is balanced. Yes. Now insert the next element. Which element we have inserted last? 8. After that, insert 50. Where to insert 50? Left or
20.
what is the balance factor here?
0.
Balance factor
1.
here. Here.
-1.
Here.
2.
Tree is balanced or unbalanced?
Unbalanced.
All of you are dictating at the same time or not? Or otherwise, after completion of all the explanation, you can draw by your own. So, what kind of rotation you need to apply here and where to apply? Now I am expecting the answer from your side. I will not say anything here. Now here I have inserted 50. So tree is unbalanced. Now how to convert this tree into the balanced tree? कोणतं ऑपरेशन परफॉर्म करावं लागेल? लेफ्ट रोटेशन, राइट रोटेशन, right left rotation. Okay, where to perform and how to perform? जर मला हे चेंज करायचं असेल, हा 20 मला इथं आणायचं असेल, कुठलं लागेल रोटेशन? Which rotation is required?
Left, right, sir.
Left, right.
Left, right.
Left, right. So
Right.
first shift the
20
20 at
will-
left, right? So 20 at left.
Left.
So 20 will
10
take
will
the
be replaced
ownership
by
of
20.
10, and after that
50 will be replaced by 20.
20 will take the ownership of 50.
50.
Now, so what will be the final tree? So I'm explaining final tree. So 20 here, right? Now after that, so if 20 is here means so at right, so obviously 50 will be there. 60.
60.
At left of 20.
10.
10.
8.
8. And
15.
is it right?
Yes, sir.
Now what is the balance factor of 60?
0.
What is the balance factor of 50?
-1.
What is the balance factor of 8? What is the balance factor of 20? 0. Now the tree is balanced? Yes? समझते हैं ना?
Yes, sir.
Next, which element you want to insert? Next element?
32.
32. Where to insert 32?
Left of 50.
Left of 50. Okay, so what is the balance factor of 32? 0. Now
0.
here it will become
0.
Is there any changes is required here?
No.
No, sir.
Now next element. 46. Where to add 46?
A right of 32.
Binary search tree. So 46 is greater than 20 or less than 20? Right of 20. Come here. So 46 is less than 50 or greater than 50? At left or right? 42 could I? Left. Come to 32. It is greater than or less than? Right of
32.
So 46 is at right of the 32. Now here balance factor is 0. Here what is the balance factor of?
-1.
-1. So here 0. Here
1.
1. After that here
-1.
tree is balanced.
Yes.
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 Now next 11. Insert the 11. So where to insert 11?
Left of 15.
Left of
15.
So what is the balance factor of 11? 0. What is the balance factor of 15?
1.
What is the balance factor of 10?
-1.
Now what is the balance factor of 20?
0.
Now tree is balanced or unbalanced?
Balance.
Balanced. Now insert the last element 48. Where to insert 48?
Right of 46.
32.
46.
Right of 46.
Right of 46. What is the balance factor of 48?
0.
46.
-1.
32.
-2.
-2. Here 0. Here
2.
2.
what is the balance factor of 20 now?
-1.
-2.
Minus
1.
but here the tree is balanced or unbalanced?
Unbalanced.
Unbalanced. So why?
50 is a balance factor.
So this unbalanced structure we need to convert it into the balanced structure. So for that purpose which operations which rotation you need to perform? कोणता unbalanced part आहे? This one. Now which operation, which
Left, right.
rotation you need to perform here?
Left,
Left, right.
Left, right?
left rotation.
Single rotation. So it will not work by using single rotation.
Left operation.
Work, sir.
Left rotation करू शकता है?
Yes, sir.
After performing left rotation, so what will be the final tree? So 20, 10, here is the 50, 8 as it is, 50 as it is. Right. Now, so what we will do, 60 will be as it is here. Now, you want to perform which operation?
Left.
Left rotation. So 32 will be
Plus
and
by
left of 46. So 46 will take ownership of whose 32. So here 46 will be there, right? And at this side 48 and here 32. Now what is the balance factor of 11 now? 0 here plus 1 0 here
-1.
minus 1 here 0 0 0 here
1.
plus 1 now here.
0.
Now the tree is balanced. Now the tree is balanced. All the balance factors are belonging to 0, plus 1 and minus 1. So now finally we have constructed the AVL tree. Now all of you understood the construction of AVL tree? Yes or no?
Yes, sir.
Now whatever the steps I have written here. So from the starting onwards, so all of you repeat or all of you dictate it in your notebooks. If you have understood, so definitely you are able to write. So write down the example, construct the AVL tree from following element and solve all the steps. So whatever the steps I have discussed here. So all of you have constructed, all of you have dictated all the steps. So whatever the steps we have seen. Now here afterwards, simultaneously, you can dictate the steps. Now all of you have completed? Yes.
Yes, sir.
Okay. Now we'll see the next part, that is the deletion in the AVL tree. Now simultaneously, I request all the students, so simultaneously you can dictate the steps. Now these steps are not available in the notes, right? So this construction of the AVL trees, and after that, whatever the next point we are going to discuss. So this point you can dictate in your notebook. So this will be not available in your notes. So next step is the now I will explain how to delete the elements in the AVL tree, and the same thing you need to apply for the next example. So deletion in AVL tree. Deletion in the AVL tree. Now this deletion is divided into two parts. So first type is at root level, or in short I would say R also, right? So root level. So you can consider R of 0, means 0 balance factor. In case of 0 balance factor, in case of 1 balance factor, how to delete the element, and in case of -1, right? Now in case of except all these things, so 0, 1, -1. So is there any other balance factor will be available? No, because if other balance factor is available, so immediately we need to apply the rotation to convert the unbalanced tree into the balanced trees, right? Now here, so these are the three types. So we will see how to delete the element by considering these three types. Now another type is the second type is at leaf node or at leaf level, or here I will say right at leaf level. So here again, so L of 0, L of 1, and L of -1. Right. So simultaneously, all of you have dictate these points. Now we'll see the first type. Now after that, all of you write down the algorithm. So first dictate the algorithm. So algorithm. So in that, the first step, or we'll say it is A. Write down the point A. Remove the node with the following cases. A. Algorithm. After that, write down the algorithm first. So all of you are writing the algorithm? Yes or no?
Yes, sir.
Okay. Now write down the title algorithm. So in that, write down A, or you can write 1. So remove the node with following cases. Remove the node with following cases from binary search tree. From binary search tree, or in short you can call BST. Remove the node with the following cases from binary search tree. So first case is here, no child. First case is no child. Second is one child. And third case is both children available. Under this A, so three cases are there. 1, 2, 3. One is no child, another one is one child, third one is the both children available. Now point B. So here in the algorithm B. So calculate balance factor. So after removing of the child, so we need to calculate the balance factor, right? So write down the step B. Calculate balance factor again. Calculate the balance factor again. If tree is imbalanced, so then balance it again. Then balance it again. Right? If it is imbalanced, so you need to balance it again. So how to balance? How to convert imbalanced tree into the balanced tree? By using the rotation. Good. Now next, C steps. A is nearest ancestor ANCSTOR of deleted node. A is nearest ancestor ANCSTOR of deleted node. If deleted node is from left subtree of A, if deleted node is from left subtree of A, then it is called type L deletion or left deletion. Otherwise, it is called type right deletion. Left subtree मध्ये असेल तर left deletion, right subtree मध्ये असेल तर right deletion. Yes.
So sentence repeat.
Last sentence I will repeat. If deleted node is from left subtree, if deleted node is from left subtree of A, then it is called type left deletion. Otherwise, it is called type right deletion. Type right deletion. All of you have written the steps.
Yes, sir.
Actually, so here so type R and type lib. So actually, this is not a root and lib, I think. So this is the all of you do the correction here. So actually, this is right and this is left. Actually, this is left and right. Now we'll see the types, right? Now here the first, I'll draw the one simple diagram. So 8, 5, 3, 7, and 10. So what is the balance factor of 7 here?
0.
1. Right. So here all the balance factor is here 0, 0, 0, 0, and here is the 1. Now suppose I want to delete the 10. Now, is it possible to delete? Now this is at which side, right side or left side?
Right.
So it is becoming to which type? Type right or type left? Type right. Right. Now here, so right at 0 level, right? So here the balance factor R0 will say, right? So what is the balance factor? 0. Now I want to delete this 10. So how to delete? Now here the balance factor is 0 to every leaf node, right? So here 0, 0, 0, 0. So this will come under the right 0, right? Now 10 will be deleted. So how it will be deleted? So after deleting this 10, so what is the balance factor of 8? What is the balance factor after deletion of 10? So what is the balance factor? 2. Now here 2, here 1, and here 0. Right. Now what do you need to do?
So 7
Rotation.
One more is. So here 7 is there. So here 0. 2 will remain. Now what do you need to do here? So which operation you need to perform? Right rotation. So to convert, now how to perform right rotation? So after performing, so 5 will take the ownership of 8, right? So 5 will take the ownership of 8. Now 8 will goes to the right side of the 5, and here 7 will goes to the left of 8, and after that, where is 3? 3 will be remain. So what is the balance factor of 7 here? What is the balance factor of 8? What is the balance factor of 5? Now it is balanced.
Yes.
Now what we have done? So we have deleted one right subtree element. Right subtree element. So that's why we are calling this is the type right. Right. Now next situation we'll consider here. Suppose you have element like this. Now what change we have done here? So how many elements are there? Now what is the balance factor here?
-1.
-1. Now what is the balance factor here? +1, 0, 1. Now this will come under the type R1. Sorry, not R1. So here minus balance factor is there. So R-1, right? Because we need to perform this rotation. Now delete the 10 right side element. Now how to delete? After deletion of this 10, so what will be the tree? 8, 5 and 7. Now here -1, 0, and here is the
2.
2. Now it is balanced?
No.
No. After deletion of this 10, so this is unbalanced. Now, what type of operation, what type of rotation you need to perform?
Left, right.
Left, left, right. So here, double rotation you need to perform, right? So 7 will take the ownership of, directly I write the final. 7 will take ownership of 8, and after that 8 will be at right, and 5 will be at left. Now what is the balance factor of 7? 0, 0, 0. Right. This is this type is belonging to the R -1. So why -1? Because here -1 is there at this level. Now next situation. Next example we'll consider to delete the 10. What value we have considered here? 5 and have the value count. Is it visible to all?
7, sir.
Have the value, have the
7.
3.
7 right side loading. 3.
3.
Because less value is required. 3. So what is the balance factor here? 1,
1.
0, 1, and here is the 10. Now this time is coming under the R1. Right? Why 1? So because here balance factor is positive. So after deletion of this 10, so what is the tree? 8, 5, and 3. Now what is the balance factor of 3? 0. What is the balance factor of 5? 2. Now is it a balanced? No. Now how to convert them into the unbalanced to the balance?
Right rotation.
Right rotation we need to perform. So 5 will take the ownership of 8, and here 3 is at left and the right, 8 is at right. 0, 0, and 0. Now this type of deletion is called as a which type? R of 1 type, right? हे R of 1 का म्हटलेलं आहे? इथं जे बॅलन्स फॅक्टर येत आहेत ते काय आहेत? पॉझिटिव्ह आहे, म्हणून पॉझिटिव्ह आहे. जर इथं मायनस असता तर मायनस. जर इथं या लेवलला जर समजा इथं 0 असतं तर
0.
R of 0. लक्षात आलं सर्वांच्या? So these 3 types. So intentionally I am considering the example related with the respective types. So 3 types of examples we have discussed. Type R0, R1, and R-1. Now we'll see the left type. Right? So when you will delete any node, so you need to check the balance factor. Right? And if the balance factor is okay, or if the tree is balanced, so there is no need to do the changes, and if the or no need to go for the rotation. If the balance factor is except 0, 1, and -1, so you need to go for the rotations. Now next left. Now for the left, now you can suggest me the tree, or in the same tree what kind of modification is expected. So here is the 5, here is the 20, 10, and 26 greater than. Now what is the balance factor of 20 here? 26, 10, 20, here
-1.
-1, and here 0.
0.
Now I want to delete the 5. 5 is the left element. Now, but what is the balance factor here at the same level? At right side?
0.
Means it will come under the
LG.
L of 0. Now delete the 5. So after deletion of 5, what is the tree? 26. Now what is the balance factor of 8 here?
-2.
-2. It is a balanced or unbalanced?
Unbalanced.
Unbalanced.
Now how to convert them into the balance? Which rotation you need to apply here? Left rotation can I apply here? So 20 will take the ownership of 8. Left rotation. Here. 26 and so 10, where to add 10?
Right.
Right. So here I have applied the left rotation. Here I have applied the left. Now what is the balance factor here? 1 here. And here is the 0. Here is the 0. Right. Simultaneously, all of you have dictate the steps. Yes, dictated. Now, next scenario we'll consider. So you have a tree like this. All of you give attention. Here. So what is the balance factor in that case? So if you have only 26 minus 1, right? And here same. Now, if here the -1 means this type is coming under which one? L -1 or L of what? L of -1. Now delete the 5. So after deletion of 5, so the tree will be like this. Now, how to convert this tree? Which operation you need to perform here? Left operation, and here you will get the final tree like this. So 0, 0. Right. Now after that, next one. 16. Right. Here, what is the value? 1. Now, here I want to delete 5. Now, this type of deletion is coming under L of what? Online student. Hello.
L of 1.
L of 1. Okay. Now, after deletion of 5, so what will be the tree? So 16. Now, what type of operation you need to perform? इथं कोणतं ऑपरेशन करावं लागेल? Right, left. Double rotation you need to apply here. Right, left. Now, after applying right, left, so what will be the answer? Final answer. So 16 will take the ownership of 16. Right, and here is the 20, and here 8 has it. Right. Now, in this way, we will perform the which operation? Delete operation. Now we have seen how many operations on the AVL tree. First one is the insertion, and after that deletion, right? So deletion, the two types of deletion, one is left and another one is the right. So left means, so if you are deleting the left subtree node, so left deletion, and if you are deleting the right subtree node, right type of deletion, right? Now again, right, R of 0, R of 1, R of -1. So how you are deciding this? So if their sibling, we'll say sibling node. So here 5. So what is the sibling? 1. So sibling node balance factor we are considering. If the sibling node balance factor is 1, so it is coming under the L1. If the sibling node balance factor is 0, so it will come L0. If the sibling node balance factor is -1, so it will come under the L-. So same is for the R. Now all of you understood. So these type we are deciding by considering the what element you are deleting and sibling node at the another side. Sibling node balance factor of the another side we are considering to decide these types 0, 1 and -1. ठीक है हे लक्षात आलं का सर्वांच्या हे टाइप कसं लक्षात येईल all of you understood those who are attending online yes or no
Yes, sir.
okay now any question any queries related with the AVL trees so we have discussed about the construction of the AVL trees and after that we have discussed about the deletion also now I'm expecting one example from your side so everyone will solve. So here I will give the assignment related with the AVL also. Already I have given the assignment related with the B tree and B plus tree. So now one example, at least one. Yeah. एक फक्त example देतो, जास्त नाही. Construct an AVL tree. Construct an AVL tree. All of you write down. Construct an AVL tree from the following element. Construct an AVL tree. AVL tree from following element. Following element. Insert. First you perform the insertion operation. Insert 10, 20, 50, 25, 30, 16, 18, 19. And after construction of the AVL tree, delete 30 and delete 30. Now this is an assignment for you all. Now here the AVL tree. So this unit is completed. Now this is a very small unit, right? Only concept of AVL tree is there. Now, any question, any queries? Is it possible for you all so to evaluate this construction of AVL tree and deletion of the 30 element? So online student, so whatever the points we have discussed today, so all the points all of you have understood. So if yes, you can write in the chat box yes. If not, so you can unmute yourself and ask the questions. Now here we will stop. So if you are having any questions, so you can ask. So otherwise we will take a break. And from the next session onwards, so we'll start the last unit of the data structure, that is graph. If you are having any questions, so you can ask. Otherwise, you can drop the session, no issues. Thank you.